I prepared an earlier video which was modeling a rotating disk using the inertial relief approach. Now, what I would like to do is something along the same line, except that inertial relief is not used. Instead, we have a rotating flywheel, a little bit more complicated than the one that prepared, which is solid disk. And this is rotating at a constant angular speed about an axis, as shown here. However, I will be using symmetry or what is called the cyclic symmetry in order to model 1/8 of this instead of modeling the entire geometry. Because when you think about it, that's the minimum geometry that's needed to see how the stresses look like throughout the entire full flywheel model. Let me see now. I prepared something similar like this maybe a year ago, but it was for using solid elements. So what I would like to do today is model this thing with shell elements. Okay, so let's go ahead and start with the generative shape design because we're going to be doing a surface first. So on this uh, on this plane, I will sketch. The dimensions that I use are similar to what I did in the rotating disk with inertial relief. So it's going to be a circle here, and the diameter of this is 600 millimeters. Yep. Okay. And then I'm going to make a circle up here. The diameter of that is 100, and it's positioned 200 millimeters above that axis. So one of the reasons that I want to do this problem is that there's a few things that you may find useful in 3D experience when you do a simple geometry like this. You may already know it, which is fine, but okay. Now, what I like to do is I would like to uh, rotate this and create basically three instances of the circle. So what we do is we go to this toolbar, and one of them is rotate. See that? Rotate. Rotates an element with replication. Okay, so let me move this thing out here. First of all, what is it that I want to rotate? I want to rotate this. And when you look at this tool palette, it says center point. I want to use this as a center point. Okay, and this is going to be this. I'm going to select this line here, this axis. Notice that I'm creating one replicate of this, but I don't want, I want four of them. Three instances actually, that's what I want. I want three instances, including the original one is going to have four. Let's position them. Yeah, that looks good. Now, the problem is that if I try to fill this thing in the generative shape design, it says that you'll see what it says. I can't do it. So let's exit this. Okay, exit. And I'm going to try to fill it. So on the surface, fill. Now, the thing that you want to fill is this. The problem is that this has interior circles in it, okay, interior boundaries, and it won't let me do that. Now, you might say, okay, can I do this then? Say, okay, can I do inner boundaries? If I try to do this and select that, again, there's going to be an issue. So you say, fine, cancel that. Let's go back to that sketch, and I'm going to use a profile. It's called feature profile output feature, not profile, output feature. And there's we can pre-select these four of them and do it at the same time or do one at a time. Let's try to do let's try to do it one at a time. So here's one. Notice that it kind of became thicker. You can see that. Another one is here. See that? Output feature has been created. And another one. And another one. You see that this will allow us to do exactly what we were planning to do. This has created, by the way, an output for features here, output features. Exit, exit. Good. Now we go and fill. Read this thing carefully. Outer boundary is this. For the inner boundary, you put the cursor there. You start selecting these one at a time. The first one is selected. Second one, third one, and the fourth one. Okay, so that's good. There we are. Now you can hide any of these things that you don't want. Right click, hide these. Okay. Hide the sketch if you don't want to see it. Now, later on, first of all, I want to take 1/8 of that. And so to do that, I'm going to make several cuts here. So first of all, let's go to the, I think it's under wireframe. Let me create a plane that's at 45 degrees to this vertical plane. It doesn't matter which one, but let's say this one is, I believe, is the XZ. Okay, so plane. The method of making the plane is no angular normal to a plane. A rotation axis is Z. Now, Z axis, okay? And the reference plane is this XZ, and the angle is 45 degrees. Notice that a plane has been created at 45 degrees to that original vertical XZ plane. Now we start cutting. So let's go to the transform, the place where you have the saw. So that's split, right? Split, read it carefully. Element to cut is that surface. The cutting element, for example, let's start with the XZ plane, vertical XZ plane, okay? And by the way, if you want the other side now, just click on this guy. See that? There. Say okay. And now we're going to cut it with that angle at plane at a 45-degree angle. One more time. Element to cut is that surface. The cutting element is that plane that we just created a minute ago, right there. And if I'm on this side instead, just make sure you click on this icon there, the other side. See that? The other side. And we say okay. So what I have created here is actually this. Now, I also need to coordinate system. I need a feature later on to say this is rotating about an axis. I don't have a feature. I don't have a line here, but the easiest way to achieve that is to go to the wireframe, create a coordinate system. Notice that it automatically create a coordinate system for you right there. And I can use that Z axis of it later on as axis of rotation. You say, okay, now notice that this edge is not in any one of the traditional XZ, YZ, or XY plane. So I'm going to also create a coordinate system here, which is lined up with that edge. And for the origin of it, I'm going to select, let's see now, for the origin of it, I'm going to select this point. And I'm going to make sure this line, for example, is either X or Y or Z of this local coordinate system. For example, for the X, I select this, and it lines up the X axis along that. This coordinate system is going to be later on to impose the boundary conditions, symmetry boundary condition on this edge. Okay, so okay, good. We are pretty much done here. So let's go ahead and create a material here. So we go to tools, create a material. I'm going to call it edge symmetry. Edge symmetry. February 24. February 24. Simulation domain has been checked here. That's good. We say OK. And it's going to create that in my library. Edge symmetry February 24. Right click, apply. I'm going to close that, apply it to this model, and we're going to fill in the numbers now. So we go here. Okay, so structures, general, we need the density because the centrifugal force is operating here. So we're going to go to 7850, which is typical for steel. And then we're going to go to Abacus Multiphysics, mechanical, elasticity, elastic. Let's put the properties of steel. 200 gigapascal for Young's modulus, and Poisson ratio 0.3 or 0.29. Say okay? Good. Now that we have created the material, we're going to go to structural models creation. You click on standard, just accept the defaults. All right, now are we going to mesh it? Mesh? Well, we have a choice of doing it with a three-noded element or a surface quad mesh if possible, or a combination triangle mesh or quad. I'll do a quad to see how it turns out. Let's see how it looks like. Yeah, that's pretty much it. I mean, let's make this thing 10. Okay, good. Get out, by the way, I can't remember whether it's a linear or parabolic. It doesn't matter. The properties, you click on the properties and shell section. You select that. The entire model is created. A thickness of 16 millimeters. These are the dimensions that I took from that inertial relief example. Say OK. Good. Now we're going to go to structural scenario creation. For the finite, it's a structural problem. And we're going to select the finite element models that were created. This matches the thing in the tree. You can see that. All right. Now we're going to go procedure. It's going to be static, but we want to do linear analysis, so I'm going to uncheck the include geometric nonlinearity. Okay, so now let's do the load. So you go to load and expand this toolbar, centrifugal force. It says the whole model, obviously, because this is a body force. Axis of rotation, I can select that Z-axis, and I put down about 8,000. I think that example said 1,000. Well, how about I put 9,000 RPM? Turn okay, good, and we say okay. Now let's do the edges. So restraint boundary condition. Let us do apply displacement. So this edge and that edge, they lie in the there must be an easier way of doing this thing because I don't like the way this thing works. Cancel that for a second. Cancel that. Let's try this one more time. Uh, Fixed displacements. Let's check this fixed displacements. Yeah, that's what we want. So this edge and that edge. Okay. Uh, these two edges lie in the XZ plane of symmetry, so they don't move in Y direction. Rotations are exactly the opposite. This one, on the other hand, does not lie in any of these planes that I selected, but I can go and select my coordinate system, the local one that I created. Remember I created this? Oh, I'm sorry, that one. Sorry, this one. Cancel that. Try it again. This edge lies in the local, well, maybe I should say specify. Yeah, specify, specify. Oh, should be either local or specified. Let me see for a second. Can we do it from the tree? Access system one. This was the global one over there. Fine. But I want a access system. God. Okay, sorry. I was selecting local, and then I have to select this next box. Let me show you again. Cancel that. Okay, let's try it again. Here, fixed displacement. This thing, the support is that edge. Okay, good. It in a specified coordinate system, and go and select the, or maybe I should say local. Yeah, local, not specified. You select the access system, you put it there, and then go and select whatever you created. You created this. Now, with respect to this, it lies in its x. If I'm not mistaken, this says xy, and therefore does not move in z, and rotations opposite. And then I say, okay. There are other ways of doing this thing, by the way. That's pretty much it. So let's see now. Yep. So let's go ahead to simulate. Let's do a model check. Let's do a simulation check. Any obvious errors that you may have is going to pop up here. And that's very fast. Remember, there are two axis systems here. One of them I used to specify rotation about its z-axis. The other one was for coordinate system on that slanted edge that I struggled with a few times. Eventually got it to work. Okay, that's pretty much it. Okay, very good. And finally, simulation. Give it a minute. I have a feeling that this will bomb out because the entire thing is free to move as a rigid body in the vertical direction. Did I not fix it? I'm not sure whether I fixed that. Well, I guess not. There we are. uh, yeah, must have been okay. So yeah, so let's see. Now let's also plot. I'm surprised because these restraints, let's check something. Let's make sure that this is not too free to move as a rigid body in the vertical direction. So let's go to this structural scenario, structure analysis under restraint. Okay, let's check what we have. Let's check this one. Remember, this one was no displacement in, that one was these two edges, I believe. Fixed displacement 1. No displacement in Y. Oh, hang in there. Global, no displacement in Y. That's correct. Rotations opposite. The other guy was no displacement in Z. Rotations opposite. I mean, this is too free to move as a rigid body in the vertical direction, but I suspect that internally is taken care of because there's nothing in here which actually prevents the motion in the vertical direction. However, uh, it doesn't do it. It just ran, and I suspect that That's internally taken care of. It doesn't happen in other software, some other software. But anyway, let's go back to results. Now, I want to find the stress distribution along that line, okay, or maybe along this line. How about that? So the way to do that is you go, for example, you say, okay, give me the plot, and here is a uh, uh, here XY plot. No, right there, XY plot from a path. Now I don't have a path, but what I can do is I can create it right here. I can create it. And there are different ways of doing it. I can do it by node, you can do it by point, or you can do it by geometric edges. And I'm going to select this geometric edge. Okay, good. And what is it that I want? I want, for example, one mesostress. Okay, that's fine. One mesostress along that path, and there we are. So this gives you the stress distribution along that path for the one meter stress distribution. In the other video that I did, inertial relief of a rotating disc, I did not have any restraints. Here I had to have, because I specified, symmetry planes. That's why it worked. There I didn't have any restraints, and I applied inertial relief, and it took care of it. I'm a bit surprised here that there's nothing that's stopping this thing from moving up and down, but still it ran. So that's surprising to me. Good luck.